Hi, third grade. Welcome to our last week of online learning. We are going to close this lesson out with continuing on collecting data and organizing data. We're going to keep on going with lesson 2 with our objective, working towards rotating tape diagrams vertically. So for some fluency practice to get us started, we're going to start by group counting on a vertical number line. Our question asks, what is halfway between 0 and 16? So we have a vertical number line here with 0 at the bottom. Notice how 16 is, and all the way up here, 16 lies right here. So we have to figure out what is halfway between 0 and 16. The easiest way to go about this is to look at the number 16 and cut it right in half. If I cut 16 in half, I know that that's 8. So my right in between, halfway, would be 0, 8, 16. All right, guys, we're going to do some fluency practice. So we're going to start by counting by 2s to 20. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Now we're going to count by 5s to 50. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. All right, and lastly, we're going to count by 10s all the way up to 100. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. I hope that you guys got a chance to count along with me. Don't forget to be practicing at home. We're going to keep on going. We're going to take a look at this tape diagram. I want us to think of a multiplication equation that would represent the total value of this tape diagram. So what that means is we're going to take a look. We're going to count how many parts are in this tape diagram, and we're going to see what is the value for each part. So let's think of a multiplication equation that represents this. So first, how many parts are in my tape diagram? I see 1, 2, 3, 4, 5, 6, 7 parts. I see 7 parts in my tape diagram. Each part is represented by the number 4. So it looks like I have the equation 7 times 4. Now I could either skip count 4, 8, 12 onto the last number, or I could solve this multiplication problem. 7 times 4 equals 28. We're going to keep on practicing. What is the value of each unit in tape diagrams A and B? So for tape diagram A, I have 4 units. Each unit has the value of 8. That's the equation 4 times 8. 8, 16, 24, 32. Skip counted to find my answer. Now we're going to take a look at B. We're going to find the value of tape diagram B by solving a multiplication problem. So let's take a look. How many parts does this tape diagram have? 1, 2, 3, 4, 5, 6, 7 parts. Seven parts with the value of 8 each. My multiplication problem is 7 times 8. We're going to go ahead and skip count to find our answer. So we're going to count by 8s 7 times. 8, 16, 24, 32, 40, 48, 56. 56 is the total value of tape diagram B. we're going to go ahead and write that in there. So in this slide, we took a look at two tape diagrams. We made multiplication problems that represented them, and we solved to find the total value. So on to our application problem. So I hope that you guys have your scrap paper out with pencils. So I'm going to go ahead and read this out loud, and then I'm going to walk you guys through how to solve. When I'm done reading this out loud, I'd like for you to pause the video and try it on your own. Risha played in 3 basketball games. She scored 12 points in game 1. She scored 12 points in game 1. She scored 8 points in game 2. And 16 points in game 3. Each basket that she made was worth 2 points. She uses tape diagrams with a unit size of 2 to represent the points she scored in each game. How many total units of 2 does it take to represent the points she scored in all 3 games? Okay, so this is a multi-step problem. I just want to review quickly some vocabulary that this application problem has included. So we know that she played 3 games. We know that she scored this many in 1, this many in number 2, and this many in number 3. We also know that each basket that she made was worth 2 points. Just in your standard game of basketball, every basket you make is 2 points unless it's a 3-pointer. But it doesn't appear that Risha made any 3-pointers in these games. So we're only talking about each basketball going in the hoop equaling 2 points. She's going to use tape diagrams with a unit size of 2. So when she talks about a unit size of 2, I'm going to go back to this slide that we were checking out. And these 2 tape diagrams, each of these have a unit of 8. So although there are 4 pieces, each of these 4 pieces represents 8. That is the unit. So for this problem, each square of your tape diagram would equal 2. So she's going to first use tape diagrams with a unit size of 2 to represent the points scored in each game. So before you pause, I'm going to give you some information to go off of. I should see 3 tape diagrams. I should see 3 tape diagrams that are different. My first tape diagram should equal 12. Each box should have a 2 in it. My second tape diagram should equal 8. Each box should have a 2 in it. And my third tape diagram should equal 16. Each box should represent 2. Okay, go ahead and pause. Okay, let's take a look at what you guys could have done on your paper. So here I have 3 tape diagrams. Game 1 is right here. Game 2 is right here. And game 3 is right here. In game 1, she scored 12 total points. 2, 4, 6, 8, 10, 12. She scored 12 points, 6 units of 12. The value of the unit is 2. In game 2, she scored 8 points. 2, 4, 6, 8. It took 4 units of 2 to equal 8 points. And in her last game, in game 3, she scored 16 points. 2, 4, 6, 8, 10, 12, 14, 16. It took 8 units of the value 2 to equal 16 total points. So now the question says, how many total units of 2 does it take to represent the points she scored in all 3 games. Okay, so here we have our representation. We have game 1, game 2, and game 3. Next to it, I've labeled this many units, this many units, and this many units. We are going to need to add up these units in order to solve this problem. How many total units of 2 does it take to represent? So, I'm going to reveal the work. So, the total units of 2, we had 6, we had 4, and we had 8. When you add it all together, we get 18 total units of 2. 18 total units of 2 represent the points scored in all 3 games. So this is just like we were doing in the beginning of the year, guys, when we were working on tape diagrams, when we were really focused on multiplication. So instead of using arrays and X's and circles to represent multiplication, we're just using a tape diagram and writing numbers inside the boxes to represent the value. If you guys have any questions about this application problem, please reach out. We're going to keep it moving. Let's take a look at our concept development slide. So, our problem asks, how are the vertical tape diagrams different from the picture graphs? So, you might say, well, these vertical tape diagrams, they have numbers, they have units, and in a pictograph I see pictures and I see keys. That's one difference. We know that our tape diagrams are connected in a vertical manner, whereas the pictures in a picture graph are usually drawn independently. The units in the vertical tape diagram are labeled, but in a picture graph, the value of the unit is shown at the bottom, typically the key. So now I'm going to ask for you to write a multiplication equation to show the value of game 1's tape. So when I take a look at our application problem and I look at game 1, I see 1, 2, 3, 4, 5, 6 units of 2 each. 6 units at 2 each, that's the multiplication, 6 times 2. 6 times 2 gives us 12. What is the value of game 1's tape? The value is 12. And how do you know that the unit is points? Well, when we use our read, draw, write strategy and we read the problem, I'm highlighting specific information and I just so happened to underline that each basket that she made was worth 2 points. This is information that they gave us. They told us this. We did not have to guess about this information. So the information was provided. And write a title on our vertical tape diagrams to help others understand our data. So what that means is if you guys took a look at this, what would you maybe call it? What would you call these 3 tape diagrams all together? Would you call it Risha's game day, Risha's points, Risha loves basketball? I might call it Risha's total basketball points. Okay, so you want the title of your tape diagrams, charts, pictographs, whatever it may be, you want it to be applicable to the situation that you are trying to inform people about. Alright guys, we've reached the problem set portion of our online online video. So this part, I'm only going to have you guys do number 1 on this side. And we're going to go ahead and go over that on Wednesday's Zoom lesson just because I don't exactly have the tools right now on Google Slides to draw this out for you in a way that I would be able to go over it. So I just really am hoping for you guys to try your best, which I know you always do. So problem set, question number 1. I'm asking you to find the total number of stamps that each student has. I'm asking you to draw a tape diagram with the unit size of 4 to show the number of stamps that each student has. The first one has been done for us. So if we look at Dana, we have a tape diagram with 4 units with 4 each. That's because it's been told to us that each unit is going to equal 4. Well, when I look at Dana, I see 4 rows, I see 4 columns, so it makes sense. I have 1, 2, 3, 4 units with the value of 1, 2, 3, 4 in each. Tanisha, for example, would have 2 units. She would have a tape diagram of 2 squares with 4 in each. So I'd like for you to go ahead and interpret this information and create 3 more tape diagrams. We're going to quickly do some debriefing. So I just wanted us to think about in what ways that vertical tape diagrams relate to picture graphs. So we talked about how they are different, but we didn't really touch on how they are the same. So you might say that both graphs provide us with an organized way to see data. That would be correct. Both graphs also help us collect how does multiplication help you interpret the vertical tape diagrams on the problem set? So instead of taking a look at this tape diagram and going 4, 8, 12, 16. Okay, I can take a look at this and I can go, oh, well, I'm going to label this 4 times 4. And my fast brain, just like yours, knows that that multiplication fact, 4 times 4 equals 16. So right away, we don't have to bother with skip counting. We just know that this tape diagram, we look at it and we say, oh, that's 16. Oops. Okay, we're going to go along to our exit ticket portion. So, the chart below shows a survey of the book club's favorite type of book. So, let's take a look at this chart. The chart's name, book club's favorite type of book. Okay, on the left here we have type of book, mysteries, biography, fantasy, and science fiction. The number of votes. For mystery, we have 12 votes. For biography, we have 16 votes. For fantasy, we have 20 votes. And for science fiction, we have 8 votes. Well, I'm asking you to draw tape diagrams with a unit of 4 to represent the book club's favorite type of book. So, draw tape diagrams with a unit size of 4 to represent the book club's favorite type of book. So, tape diagrams is plural. It's asking us to draw a tape diagram for mystery, for biography, for fantasy, and for science fiction. So you're going to use a tape diagram to show me 4, 8, 12. That would be 3 units of 4 for mystery. I'm going to see if I can go ahead and draw that. 4. Oops. 8, 12. It might look a little something like this, where I have each of these boxes labeled with the number 4 in it. And this is my tape diagram showing the mystery votes. 4, 8, 12 would be for mystery. Draw tape diagrams with the unit size of 4 to represent the book club's favorite type of book. Well, I know that wasn't the favorite type of book, so I'm going to keep going. Like I had mentioned, I'm going to be going over this information in this week's Zoom. I am absolutely over the moon getting all of your guys' work that you've been sending me. I can tell that you're working very, very hard. I just want to remind everybody, all families out there, that I am always available to talk, clarify any information, help out a little bit with some extra work if you guys need, or if you simply would just like to talk. I'd love that. I'm looking forward to seeing you all on Wednesday on Zoom. and I hope that you enjoy your week. Thanks, guys. Talk to you soon.